All right, we're going to talk about complements, conditional probability, and Bayes' theorem. Okay, so complements. The complements, the probability of at least one. So sometimes we have this idea where we have this at least one. So we're looking at 1, 2, 3, so on and so forth. Find the probability of getting at least one of some event. So let A equal getting at least one of some event. Then the complement equals getting none of the event being considered. Okay, so the complement now is getting 0. So find the probability of the complement that event A does not occur. This is relatively easy using the multiplication rule. Okay, subtract the results from 1. That is, evaluate the expression. The probability of at least one occurrence of event A equals 1 minus the probability of no occurrence of the event. Okay, so that's kind of that at least, kind of getting you thinking of how do we use complements. Accidental iPad damage. So a study by Square Trade found that 6% of damaged iPads were damaged by bags backpacks. If 20 damaged iPads are randomly selected, find the probability of getting at least one that was damaged in a bag backpack. Is the probability high enough so that we can be reasonably sure of getting at least one iPad damaged in a bag or backpack? Okay, so here we're at least. So we're going to be looking at how do we tell if we're getting at least one. That means we have 1, 2, 3, 4, all the way up to 20. Okay, so step 1, let A equal at least one of the 20 damaged iPad was damaged in a backpack or bag. Step 2, identify the event that is the complement of A. So A is not getting at least one iPad damaged in a bag or backpack among 20 equals all 20 iPads damaged in a way other than the bag or backpack. Okay? Step 3, find the probability of the complement of evaluating P of the complement A. So the probability of complement A is the probability that all 20 iPads damaged in another way besides a backpack. So if I look at just one iPad, the probability that it's damaged some other way besides a backpack is 0.94. So if we're doing this 20 times, it'd be 0.94 times 0.94 ... times 0.94, which is 0.94 to the 20th power, right? So that's all 20. Or we have a 29% chance that they are damaged in some other way besides a bag or backpack. Okay? So step 4, find the probability of at least one being damaged. So what we're going to do is we're going to take 1 minus the probability of the complement. So 1 minus 0.290, which gives me 0.710. So 0.710 likelihood of damage, at least one being damaged by a backpack or a bag. Conditional probability. A conditional probability of an event is a probability obtained with the additional information that some other event has already happened. Okay? So notation. So here we have P parentheses B bar A bar. This denotes the conditional probability. So this is red, the conditional probability of an event B given that event A has already occurred. Probability of B given A. Okay, that's how we read that. Okay, so the probability of B given A equals the probability of A and B over the probability of A. Okay, so pre-employment drug screening. If one of the 555 test subjects is randomly selected, find the probability that the subject had a positive test given that the subject actually uses drugs. Okay? That is, find the P positive test result given the subject uses drugs. Okay? So we're right here. Okay? So there's two ways to do this. What I'm going to kind of look at here is the example that they showed you. So P positive test result. So here we have our positive test results over our total. So we go 45 over 555, right? And then we go the probability that the subject uses drugs, so that's 50 over 555, which gives us 45 over 50. Now, okay, that's kind of that back piece, the probability of A and B, a positive and using it over the total. Now, when you're in a table like this, a lot of times it's actually pretty straightforward. So given, what is our given? Subject uses drugs. So we could look at just this row, actually, and then look at the positive. So 45 over 50, which is what we got, so 0.90. Example 4. Okay, so we're going to start kind of using the base here. We're not really going to talk about what it is. We're just going to kind of look at it. So assume cancer has a 1% prevalence rate, meaning that 1% of the population has cancer. Denoting the event of having cancer by C, we have probability of C equals 0.01. For a subject randomly selected from the population, this result is included with the following performance characteristics of the test for cancer. Based on probabilistic reasoning in clinical medicine by David Eddy, Cambridge University Press. So here we have the probability of cancer is 0.01. There's a 1% prevalence rate of the cancer. The false positive rate is 10%. That is a P-positive test, given that cancer is not present, is 0.01. Okay, the true positive rate is 80%. That is, the positive test result, given that cancer is present, is 0.8. Find the probability of cancer given that the positive test result. Okay, so we're going to use this conditional probability. So I have probability of A given B. So I have probability of A times the probability of A given B. This is Bayes' theorem over probability of A times probability of B given A plus probability of A times probability of B given A. This is Bayes' theorem. Okay? So what we're doing is we're looking at this positive rate. So I have the likelihood that cancer is here, 0.01, times, if I know they have cancer, the rate that they're going to have a positive test result is 0.80. So I have 0.01 times 0.8. I have that down here also, plus 0.99 times 0.1, right? This is okay, times 0.1, which is 10%, which gives us a 0.0748, okay? So find the probability of cancer given it. Definition. Prior probability is an initial probability value originally obtained before any additional information is obtained. A posterior probability is a probability value that has been revised by using additional information that is later obtained. Okay, so that's kind of an introduction to conditional probability and how to work with it.